Welcome to Ask and Learn.
We're told the hydraulic system of backhoe is used to lift a load as shown in figure 11.48. So I've reproduced the backhoe here. There's a force from the hydraulic system acting here. That's a distance L1 from our pivot point at A. There's the weight of the arm, which acts through its center of mass. That's a distance L2 from A. And then there's the weight of the payload in the bucket that acts at a distance L3 from the pivot point. Now, the point at A is fixed, so the sum of the moments about that point is 0. And if we take counterclockwise as positive, we wind up with our moment balance is the force from the hydraulic system times L, and the force from the hydraulic system acts perpendicular to the moment arm. The weight and the load do not act perpendicular, so we need to take the side. We need to get the component that is perpendicular by taking the sine of this angle. So we get the weight of the arm times the sine of that angle is the component in this direction times L2. It's in the clockwise direction, so we have a minus sign. Likewise for the weight of the payload, but now we have L3, and again we have a minus sign here because it's acting to rotate the bucket, the arm, clockwise. So we can solve for F, and we get just this equation for our the force acting on the hydraulic cylinder. We can start plugging in some numbers. So we have the length ratio, L1 over L2 over L1. The weight of the arm is its mass times gravity, and then sine the angle that the arm is acting relative to the vertical is 30 degrees. And so we have L3 over L1 times the weight of the payload, which is 400 kilograms times G, and then again sine of 30 degrees. Now if we plug everything in, we wind up with a force of 13.8 kilonewtons. If we figure out what the pressure in the slave cylinder is, well, that's just the force acting on the bucket arm divided by the area of the slave cylinder. So we are given that the radius or the diameter of the slave cylinder is 2.5 centimeters. So it's 1 over its area is this value here, multiplying it times the force, and we get 28.1 kilopascals. Now, we're told that we have a lever arm pushing on the master cylinder, and that this lever arm has a mechanical advantage of 5, meaning that this distance here is going to be 1/5 of this distance here. We know the pressure in our hydraulic fluid in here is just 28.1 kilopascals, so we can figure out what force is acting on our master cylinder, and that is simply the pressure in the hydraulic fluid times the area of the master cylinder. We're given that the diameter of the master cylinder is 0.8 centimeters, and so we plug all that in, and we get that the force acting on the master cylinder is 1,413 newtons. And so then if we have a mechanical advantage of 5, the force acting at at the other end of the lever arm is 1/5 of that, and that is 283 newtons. And in fact, this guy should be drawn the other way.